All right, now we have this thing called joint variation. So now we have x, y, and z are three different quantities, and z varies jointly with x and y if there's a non-zero number k such that z is equal to k times x times y. Okay, so now we have two things we're multiplying by as well as that constant. Okay, so it says the strength S of a rectangular beam varies jointly as its width W and the square of its thickness T. So the strength, so that would be S. Now where's my writing utensil? There it is. It varies jointly, so some K as the width and the square of the thickness. So it's going to look something like that. My S's and fives look the same, so don't worry about that. So if a beam is 5 inches wide, so that would be the this, so that'd be 5, and 2 inches thick, so that would be a 2 squared, and then we have a k, and that's equal to 280. We just have to solve for k. So that's going to be 4 times 5 is 20. 20 goes in there, 1, 14. So k should be 14, just looking at this quickly like that. And then we're supposed to figure out how much this beam and width and inches would support. So let's make sure we have this part first right. So we do have kWt squared, and we plug that in, and we get k is 14. So we're good there. Now we just have to plug in 14 times 4 times 3 squared. And when we multiply all that out, we get 504 pounds. Okay, so that's going to be how much that beam can support based on this direct variation here. So again, we're doing I mean joint variation, not direct. The joint variation, it's a direct in the fact that it's directly done, but it's a joint because you have two values here. Sorry. So I said the wrong word. And so that's the joint variation that's between the k, the w, and the t squared. All right, so that's all I have for this one. Hopefully that will help.